Hey guys, welcome. Today we are going to talk about the Graham's law of diffusion. Now before we dig right into it, let us first discuss what is the difference between diffusion and effusion. What is diffusion, guys? It's pretty simple. It's just a flow of a substance from a higher concentration, wherever it's highly concentrated, a higher concentration to its lower concentration. Well, effusion is not very different. Effusion is again the flow of substance from high to low concentration through a narrow opening. That is the only difference. So let's try to visualize it as much as possible. So here you can see two scenarios. Right now, the red here, let's say, is the solute. The black here is the solvent. Now, how do we decide this? Whichever is more, that's the solvent, right? So, the solute is highly concentrated at this position. It will try to flow to the areas where it's low concentrated. There's no orifice or something like that. So, this is the classical case of diffusion. Now, effusion is where you have a small opening, a small orifice. So, this guys will try to spread from the high concentration to the low concentration. Now, where does the Graham's law come into the picture? Now, that is because Graham's law basically determined what would decide the rate of diffusion / effusion of a substance. So he said that the rate is inversely proportional to m, m being the molar mass. He later on gave the same relation for densities as well. So you can say that the rate of diffusion / effusion of a gas is inversely proportional to square root of mass. Okay. Now, the rate depends on other things as well. So, R is proportional to the pressure, right? High pressure, more diffusion. More area, more diffusion, and the square root of temperature and molar mass. So, guys, this is not the Graham's law. Graham's law only talks about the molar mass, right? So, we are going to use this relation to try to solve a few questions. Let us get right into it. So, find the rate of diffusion between, find the ratio of rate of diffusion between hydrogen and oxygen gases. So, let's say RH and RO. So, RH upon RO equals square root of MO upon MH, right? Because it's an inverse relationship, right? So that implies RH upon RO equals the mass of oxygen. Oxygen is O2. That means 16 times 2. That's 32. Hydrogen is H2. 1 times 2 is 2. Right? So there goes 16 square root is 4:1. That's your answer. It's pretty easy, right? Let's try to do one more. I'm going to hit a pause here so that you can do the calculation and then we'll start right into it. Here's the pause. Okay, I really hope that you must have solved it. So again, R He and R CH4. So R, again it's ratio, RHE upon R CH4 equals the square root of mass of CH4 upon mass of He. So CH4, 12 plus 1 times 4, that's 16, right? And He mass is simply 4, right? So 16 upon 4 4, and square root of 4 is 2:1. So that is your answer. I hope this really makes sense.
Try to solve this problem and leave your answer in the comments below. Want to learn more? Check out the next video. Quick reminder to subscribe to GeeklyEDU.